Hello YouTube, welcome to my channel. I'm SreeTips, and today what I'm going to attempt to do is refine the palladium that we extracted from the silver cell slimes. I've got it here in this beaker. It's been sitting there ever since I did that last video. And I've also got some other palladium precipitate from some previous reactions that I did with dimethylgloxine, or DMG. And I recovered this out of some silver that I had dissolved, and from some of my electrolyte out of my silver cell. So what we're going to do today is we're going to dissolve this in aqua regia at first, and then we're going to extract the palladium black powdered metal with some strips of pure zinc. And I'm going to do that right now for you. In a previous video, I used dimethylgloxine to precipitate the palladium salt. I poured it through a filter paper to collect the precipitate. It's a yellow fluffy precipitate that forms when the palladium mixes with the dimethylgloxine. Then I took the filter and the precipitate and put it in a beaker. Okay, in this video I'm going to start out by adding the other filters that have some dried dimethylgloxine precipitated palladium salt in them to the main beaker. And what I want to do here is get everything into one beaker so that I can dissolve everything in aqua regia. Here's one of the filters. I open it up to show you what the yellow precipitate looks like. It's dried and in a powdered form here. And I've got this in a fume hood. This powdered salt is not good to breathe. It's extremely important to not breathe this stuff. Next, I put some hydrochloric acid into the beaker with the filters. I fill it up to about the 300 ml level with hydrochloric acid. Here you can see the level is at 300. Now I'll give it a quick swirl to try to mix everything up, and then I'll put it on the hot plate and turn the hot plate up to medium. After a minute or so, you can see the solution's turning green, and then after about half an hour, this is what it looks like after it's been boiling for about a half an hour. Before I go any further, what I want to do is put a drop of my Palladium standard test solution on a piece of filter paper here, and I'm going to test the potency of my stannous chloride. This is stannous chloride. I'm going to put a little drop of that on here, and you see I get that brown stain. That means that my stannous chloride solution is good to go. I made this Palladium standard test solution by dissolving 1/10 of 1 gram of palladium in some dilute nitric acid, and then I topped it off to 100 ml, so I got 100 milligrams, or 1/10 of 1 gram in 100 ml of solution, and that'll give me a standard test solution that I can judge how much palladium's going into solution with my experiment over here. What I'm going to do now is go ahead and dip the piece of filter paper into the experiment. Get a little on the end of it. Add some stannous chloride, see if we got palladium going into solution with just hydrochloric acid. And it looks like I do. Just hydrochloric acid's putting some of that palladium in solution. Now what I'm going to do is go ahead and start adding some nitric acid here. This is a 3 ml pipette filled up to this level right here. That's just over 3 ml of nitric. I'm going to go ahead and just start dripping it in. Don't want to add it too fast. You can see we get a nice bubbling reaction there. I only got about a half ml in there before it went like that, so it's careful to add these reagents very slowly, or you could get a boil over and have some problems. I'm just going to go ahead and wait on that. Alright, this solution's been on boiling now for about a half an hour on medium heat. I turned the heat down. Get a temperature reading here on it. And I got 195.5 degrees inside that beaker. I've turned the heat down. I'm going to go ahead and try to add a little bit more of this nitric acid now. See what kind of reaction we get. I'm going to add it real slow. And I got about another half ml in there. And you can see it's highly reactive, so we got to add that stuff very slowly in order to prevent having a boil over. Solution is down to 178 now. Go ahead and try to add some more nitric here and see if we can get it all in there. All right, that's a little better. Going to try it about another 1.5 ml here. So far I've got 4.5 ml of nitric acid in there. Okay, this segment of video, it's been about 3-4 minutes since I added that last dose of nitric, and all of a sudden I experienced a runaway reaction. I haven't added any more nitric acid. I just wanted to get in close with the camera. I seen it was going to go over, so I tried to set the camera down to try to do something. I realized there was nothing I could do, so I just picked the camera back up and filmed the overflow. Disaster. Added too much nitric. Added it too quickly. You get to see the mishaps and the errors here. So what I'm going to do is I'm going to kill the power to the hot plate there. We'll let this cool down and clean it up and continue the experiment. Alright, I'm going to use a piece of paper towel here to try to sop up the overspill there. Put it in this other beaker. Okay, this is 7 years worth of experience working against me. I got a false sense of security when I lowered the temperature and I put that first 1.5 ml of nitric in. It didn't react very vigorously, so I put the second 1.5 ml of nitric in, and then 4 minutes later I experienced that runaway reaction. This is due to my lack of experience with refining palladium. I did not expect that runaway reaction, and I got a big mess to clean up here, so we'll do it and continue on. Alright, I've allowed the solution to cool down now. It's down to 84 degrees. My lack of experience in refining palladium is what caused this mishap. I've only done it a couple times, and that's what caused this problem. What I'm going to do now is try to wipe these remnants off of here. What a mess. outside of the beaker off here. This stuff is highly toxic. It's not quite as bad as platinum, but it does cause problems if you get any on you. So I want to try to avoid that. Real careful here. Try to pour this back into the beaker. Probably a mistake. Probably should pour this in the other jar, but I think there's some silver chloride that's going to form in this container, but we'll just have to deal with it. Back on the heat. Keep going. Alright, it's been back on the heat now for about 20 minutes. It's up to 150 degrees or so. What I'm going to do is I'm going to use some hydrochloric acid and a pipette and rinse down the bits of palladium salt that's clinging to the side of the beaker inside there. Now I'm going to go ahead and start adding some more nitric acid, see if we can get everything to go in solution here. This time I'm going to add it real slow. That's about a half of an ml, and I'm just going to let that react. over the last half hour, I went from 4.5 ml of nitric, which some of that was lost when the overflow happened. But I've added, went from 4.5 to 11, which is what, 6.5 more ml over the last half hour or so. Go ahead and get a temperature reading now. And we've got 177.5 degrees Fahrenheit. I think most of the palladium has dissolved now. I'm going to just let this cook for a while with the amount of nitric that I've got in there. And keep going until I see all those little yellow specks have dissolved. And we'll check the bottom of the beaker and see if we've got everything in solution, then we'll proceed from there. It's been about a half an hour since I added the last dose of nitric. Just let it set. I'm going to go ahead and get another temperature reading here. And we still at 175 or so. I've got about 1.5 ml of nitric here. I'm going to go ahead and add this to the beaker slowly. I got about half of it in there. Okay, when it's only been about a minute or so since I added that last dose, I'm going to add the rest of this for a total of 1.5 ml. I got 12.5 ml of nitric in here. I'm going to give it a quick swirl, stir it up a little. Now I want to check the bottom down here and see what kind of stuff we got left. You can see there's still some stuff that hadn't dissolved yet. So I'll just keep going with the nitric acid additions until I get all that to go into solution. Got another 1.5 ml of nitric acid. I'm going to go ahead and add it now. It's been about an hour since I restarted the experiment. What I'm going to do is let this acid react until all the fumes go away. And I'll check the bottom of the beaker and see how much is left to dissolve. And if I have to, I'll add some more nitric acid, get everything to go into solution. The palladium solution has been on boiling now for about 2 hours since that last segment of video. I've cranked the heat up and I added 4 more ml of concentrated nitric acid for a total of 18. We'll get a temperature reading here. As you can see, I got it up to 216 degrees Fahrenheit. I'm going to go ahead and turn the heat off. And we're going to look up underneath the beaker here and see what all else has to go into solution. As you can see, there's just a little bit of, looks like some silver chloride in the bottom of the beaker there. All the palladium has been dissolved now. So I'm going to go ahead and take it off the heat and let it cool off so we can filter it out. This palladium precipitate was derived from silver solutions. So there's no way of getting around having a little bit of silver chloride in there with the palladium. So what I'm going to do here is I'm going to cool it down in an ice bath to get that silver chloride to come out of solution, so that I can filter it out. Temperature's down to 106. Solution's been in the ice bath for about 20 minutes now. Got the temperature down to 52 degrees. I've got my filtering rig here cold so we can keep everything cold. I've got everything refrigerated. Had this water in the freezer. Everything's nice and cold, so when we go to filter this out, we won't heat it back up. Okay, while I'm waiting for the solution to filter out there, I've got a box of zinc that I bought here. This is pure zinc sheets. It's someplace in Ohio. I can't remember what the name of it is, but I found them online. And this is they make stuff out of zinc, and this is 99.9% pure zinc. And these are just remnants of pieces that were left over after they got done with their projects. It's 50 pounds of it, and I think I paid $85 for it. It'll last me for a lifetime. So what I'm going to do is I'm going to cut this into some strips, and then we'll use this to precipitate the palladium out of that solution. I've completed the filtering operation here. We'll go ahead and take the funnel off now. Go ahead and move this up onto the sill of my fume hood here. Now what we'll do is transfer the solution into this large 2-liter beaker. Looks like it's got some residue in it. I'm not going to add that to the main batch. I'll probably add that to my stock pot. Here I have the pieces of zincs that I prepared earlier. And what I'm going to do is I'm going to go ahead and put this zinc metal into the palladium solution. I twisted them so they don't set flat on the bottom. And what will happen is the palladium solution will react with the zinc and cause the zinc metal to dissolve. But as it dissolves, it will cement out the pure palladium metal as a black powder. The two metals trade places during this chemical reaction. The zinc goes into solution. The palladium comes out of solution as a black powder. And when we get done, what we'll have here is a green solution with some black powder in it. Hopefully, that's what I'm expecting. This is called cementing out the palladium onto the zinc. As you can see here, that black residue on top of the foam there is actual palladium metal, a black powder that comes out of the solution as the zinc dissolves and goes into solution. I'm going to add the rest of the zinc to it now. The reaction is exothermic, and this is heating up a little bit. I'm going to add the rest of the zinc in. I went and chopped up some more pieces of zinc here. What I'm going to do is go ahead and add these slowly and keep cementing out the palladium on this zinc until it won't do it anymore, or until I don't get any kind of reaction. What I'm expecting to happen here is for the solution to turn green and have the black powder, the palladium, settle to the bottom of the beaker there. I got a lot of acid to chew up with these zinc pieces. The zinc reaction is progressing nicely. I'm going to go ahead and test this solution, see if we got any palladium left in solution with some stannous chloride. And you can see by that test, nothing. Completely colorless. The solution is taking on a greenish tint, just like I expected. And you can see the black powder building up on the bottom of the beaker. There's the black powder. That's our palladium down there. As I stated earlier, I'm going to go ahead and just add this little bit of palladium solution that's left in this flask down into my stock pot here. It had some residue in it, and I did not want to add that to the main solution and contaminate the palladium in this beaker here. Here's our nice pretty zinc or palladium metal. It's a black powder, and the zinc is still reacting in there. It's turned a little slight green color. I've got one more piece of zinc I'm going to put in there, a large one. Just going to drop it in to finish the acid off. I'll be able to pick that out once all the acid has digested. I'm about 12 hours into this process now. The solution has turned back from a green color back to a burgundy color, but I can see my metal down there. It's piling up pretty high down there. Anyway, I'm going to go ahead and add some more pieces of zinc here to continue the reaction. Okay, the book calls for a little bit of hydrochloric acid to be added if the reaction stalls. I've got some zinc in there. I'm going to add just a little bit of hydrochloric acid here. Adding that little few extra pieces of zinc and a little bit more hydrochloric acid really cleaned it up nicely. I can see the little pile of black metal down on the bottom of the beaker there. And here in a minute what I'll do is pick those pieces of zinc out and we'll drain off the liquid and get our black palladium metal powder. I'm going to start drawing off some of the liquid out of the main beaker here with this pipette. That black powder is our palladium. I'm going to get some water on this right quick, dilute the acid, and then let whatever residual acid, hydrochloric acid is in there, go ahead and dissolve the rest of the zinc out of it. I'm going to add about 250 ml of distilled water. Alrighty, here's our first extraction of our black palladium powder. I've already added some distilled water. Now I'm going to put in just a touch of hydrochloric acid to just a little bit here, maybe just a few ml, maybe 5-10 ml is it. What that'll do is that'll dissolve off any residual pieces of zinc that's in the palladium black powder. I've got some distilled water and some hydrochloric acid in there with the powder, the black palladium powder. And I can still see just a few tiny pieces of zinc that's reacting in there. I want to get all that out of there. And what I'm looking for is for that fizzing action to completely cease. And when that happens, I go ahead and drain off the solution and rinse the black palladium powder real good with some fresh water. I don't see any more bubbles coming up out of my metal here, so I'm gonna conclude that all the zinc has been dissolved out of there. I'm gonna go ahead and pour off my solution now into this container, making sure my black powder stays in the main beaker here. I'm going to rinse the powder with a little bit of hydrochloric acid. Pour that off into this container. got some distilled water here that I heated up in the microwave. I'm going to add about 250 ml and give it a quick rinse with that. Pour that off into this beaker here. Notice how it settles quickly. And do another quick rinse with some hot distilled water. Here is our black palladium powder. I'm just gonna pour some water on it, put the lid on, and then when I come back out tomorrow morning, we'll continue the process. The next step in the process here is to get a weight on our palladium powder that we have. And to do that, what I'm going to do is weigh this beaker and then write right on it what the weight is. It's 115.2 grams, so 115.2 grams. 115.2. It's next morning, and what we want to do here is I'm going to pour this water off, and I'm going to rinse the black powder out a couple more times. I want to make sure all the zinc is out of that before I go to the next step. Actually, what I'm going to do is go ahead and transfer it into this little beaker right here, the one that we just got the weight on. Here's our black powder, the palladium, in the water in our little beaker here. What I'm going to do is I'm going to pour this rinse water off and give it a couple more rinses with some distilled water. And the reason I'm doing this, I want to make sure all the zinc is out of there before I go to the next step. Okay, here's our black palladium powder that's been rinsed real well to make sure all the zinc is out of it. This is the beaker it was in. If you notice, there's a little ring of black around it. What I'll end up doing is probably put some aqua regia in there, just a little bit, and dissolve that, and then add that to my stock pot. Here's our rinse water that we just rinsed the blacks off with, the black powder. And there's still a little bit of black powder that got poured over in the rinse. I'll drain this water off and I'll save that, put that in my stock pot as well. And then back here I have the wastewater from the from earlier in the video. It's got a big old piece of zinc in it, and notice how black it is. It's black as ink. And I just wanted to show how we get this to clear up. We just add a little hydrochloric acid to it. Not much. And what will happen is that will tend to make that colloidal suspension come out of solution and settle on the bottom. And then once that happens, what I'll do is get the blacks off the bottom of this beaker, add it to my stock pot as well. Now, back to our main beaker here. This is our black powder. I've got the weight of the beaker on the black, I've got the weight of the beaker written right on the side of it. And I'm going to go ahead and evaporate this water off now to get as much water off as I can and dry it to a powder. I'm going to use a small pipette here and try to get as much of this liquid off as I can before I start that evaporation process. Here's our black palladium powder that I've got in a beaker here. I'm going to go ahead and put it on the heat now and turn the heat up to low and just let that slowly evaporate off until it's completely dry. Alright, our palladium black powder is bone dry on the heat now. Here it is in our beaker. And what I'm going to do is I've got the scale turned on down here. We're going to set the beaker on here with the powder in it and measure how much powder we got. Okay, we got 115.2 on the beaker and 122.7 with everything, so that means we've got about 7.5 grams of palladium powder in our beaker. 122.7. 7 minus 2 is 5. 12 minus 5 is 7. So we got 7.5s of palladium black powder in our beaker here. Okay, the next step in the process is we're going to dissolve this palladium. Now that I know how much mass I have, 7.5 grams of palladium powder, I want to create a solution where all this is in solution that is about 20 ml per gram. In other words, I've got 7.5 grams, so I want a solution that's going to be about 150 ml. I add about 100 ml of hydrochloric acid. All right, we're going to put the mixture, the palladium and the hydrochloric acid here on some heat. And I'm going to start adding some hydrogen peroxide here. I've got some 40% hydrogen peroxide that I bought at Sally's Beauty Supply. I guess they use it to bleach hair. And this should dissolve the palladium. I won't have to worry about any nitric compounds being in there because we're not going to use aqua regia to dissolve it. We're going to be using hydrogen peroxide and hydrochloric acid. I've got the heat set on medium. We'll go ahead and get a temperature. I just set it on there. It's only been on there for about 2 or 3 minutes. It's up to 150 degrees, which is about 62 C. Turn the heat down to about medium-low. I'm going to go ahead and add a little bit more hydrogen peroxide now. Give it a quick swirl with the to mix things up. Add one more quick dose of hydrogen peroxide here. let that simmer for a while. I had the solution on the heat here, low heat, for about half an hour. We've got it at 133 degrees Fahrenheit, 56 degrees centigrades. I'm going to add one more shot of 40% hydrogen peroxide here. The solution's been on there now for about an hour. I've added about 4 doses of hydrogen peroxide. We're at 58.4 C, 137 degrees Fahrenheit, 58.4 C. What I'm going to do now is I'm going to go ahead and pull this off and pour it into this beaker. Pour off the solution that we have dissolved into this beaker. You can still see that there's plenty of black powder that has not dissolved yet. And so we'll put it back on the heat and continue with dissolving this black powder with hydrogen peroxide and hydrochloric acid. I'm going to add some hydrochloric acid to the palladium powder. And that last dose I added was not 100 ml. I said it was 100 ml, but it was only about 50. And that's what I'm going to put in here right now, another 50 ml or so. Put it on the heat. I'm going to notch the heat up just a touch here. Go ahead and start adding some more hydrogen peroxide. See if I can get all this stuff to go in solution. Quite a bit there that you left to dissolve. Alright, I added 3 shots of hydrogen peroxide. That's about 1.5 ml each. There's some tiny bubbles forming inside the solution there after I added that last 3 doses of hydrogen peroxide. I've turned the heat up a little bit too, so we've got a little bit more heat going into the reaction. Now I think this stuff's going to go a little bit better with a little bit more heat. Okay, the solution's heated up a little bit more now. I've got it at 62.6 C. 144 degrees Fahrenheit. What I'm going to do is go ahead and add another 1.5 ml of hydrogen peroxide here and watch what the reaction does. Higher heat seems to get a little bit better reaction there. It's only been about 3 or 4 minutes since that last addition. I got another 1.5 ml here. And with the higher heat, it seems to be dissolving much quicker. Put some little tick marks here for the number of doses, 1.5 ml doses that I'm adding. now, since we put that last bit of hydrogen peroxide in. We put 20 doses, and what I'm going to do now is go ahead and pour this off and see how much more powder we got to go to dissolve. Getting down there, but we still got quite a bit to go. So I'll just put this back on the heat with some more hydrogen peroxide and hydrochloric acid, and we'll just continue this process until we get all this palladium powder to go into solution. Okay, I've allowed the solution to heat back up before I started adding the hydrogen peroxide. We're at 176 degrees Fahrenheit, 79 degrees centigrade. We'll go ahead and add this one in slowly because this is a little hotter than it was before. See what happens here. It's been about 5 minutes since that rapid 20 dose succession of hydrogen peroxide additions. What we're going to do now is go ahead and pour this off. See how much more black powder we got to dissolve. Getting down there. We've got less than 50% left to go there. Put some more hydrochloric acid in. Just keep dissolving with the hydrogen peroxide. I went ahead and put the beaker that I'm pouring the solutions off into on the heat there, so I can start evaporating that down to, I need to get it down to 150 ml, which will satisfy the 20 ml per gram concentration requirement that I'm looking for to be able to precipitate the ammonia soluble palladium precipitate. got 20 doses in this little beaker here where the powder was. So I'm just going to pull the lid off of that and let it go ahead and evaporate too. There shouldn't be but just a little bit of powder left in the bottom of that little beaker. Both of the solutions have been on the heat now for about an hour. I'll pull them down here. I'm going to go ahead and pour this one off into the larger beaker. See if we got any powder left in the bottom of this little beaker. It still needs to be dissolved, or if we got it all yet. And as you can see there, we got just a touch, just a little bit of powder in there that needs to be dissolved still. So I'll have to add a little bit more hydrochloric acid and get that last little bit to go into solution. We don't have much powder left in the beaker here, so I'm just going to splash in a little bit of hydrochloric acid, put it back on the heat, and go ahead and add some more hydrogen peroxide to get this last little bit to go in solution, and then we'll be done with that part of it. Right before my eyes. A little bit more in. Just want to check on the bottom of this little beaker here to see if we got everything to go to the solution yet, and yes it has. Nothing left to dissolve, so that's complete. Now all we got to do is evaporate these solutions down so that I have 150 ml total before I go to the next step of the process. Now I'll add this last little bit of palladium solution that's been dissolved in hydrochloric acid and hydrogen peroxide to the main solution, and then we'll evaporate this down to 150 ml concentration. Okay, YouTube viewers, this is going to conclude part 1 of the palladium refining video. The video is already 1 hour long, so I'm going to have to make this a 2-part video. Once I get that solution evaporated down to 150 ml, what I'll be doing is adding some ammonium chloride to see if there's any platinum in there to precipitate the platinum out. And then once I get the platinum, if any, filtered out of that solution, I'll be bubbling chlorine gas through it to try to make some ammonia soluble palladium salt. And then what I'll do is I'll take that ammonia soluble salt and dissolve it in ammonia, filter it, and then reacidify it with some hydrochloric acid to make some really pretty canary bright yellow hexachloropalladate. It's a really pretty salt of palladium, and then we just put that in a fused quartz dish and calcine it into pure palladium sponge. I've got the other videos still coming out. I got my stock pot video to do. I've got the catalytic converters, the catalytic converter beads. Those are all coming out. This is like this one here, this palladium video is a practice run for those. I got to get up to speed with all these platinum group metal refining procedures before I can dive into those and come out with some good results. So I'd like to thank all my viewers and my subscribers. Thank you so much for sticking with me during these lean times when I'm not cranking out too many videos. I'm coming up on like 38,000 subscribers, and that's just awesome. You know, you guys are really supporting me. I like to answer questions. If you have questions, please leave those in the comment section, and I try to get to those every day and look at those and answer those as best as I can. So, well, this will conclude part 1 of the video. Tomorrow I'm going to continue on with part 2, and hopefully by the end of that part 2, I'll have you some nice pure palladium metal to show for the effort. So thanks for watching. Oh, I forgot one other thing. My sweet wife, Teresa Lynn. Hello, Teresa. She reminded me and made me promise to put this little clip in about our finances. If you'd like to support me, it costs money to run this shop and to buy the materials and all the chemicals and the glassware and the equipment and the material to refine. And so if you could support me by going to my eBay website, my eBay store. My eBay username is Baffless. That's B-A-F-E-L-O-U-S. Baffless. And I've got some really nice gold and silver items on my store, in my store for sale. These are some really nice gemstone, original, authentic gemstone rings and other things. And they're like 1/3 of the retail price what you'd pay in a jewelry store. And they're just sitting there. People, I don't know what's going on with the buying of jewelry. I guess people are holding back on doing stuff like that. But instead of going to the jewelry store and spending $1,000, you can come to my store and buy it for $300. So if you could go take a look at my eBay store, Baffless, B-A-F-E-L-O-U-S, and you could support me by buying a few of the items on there, or just one, whatever moves you. So appreciate you for letting me put that message out there. Thanks for watching.